Good evening, everyone. My name is Devika, working as Assistant Professor of Chemistry in the Department of HNS. Today, I am going to explain analysis of coal. The composition of coal varies widely, and hence it is necessary to analyze the coal to use different types of uh, by using of this analysis we can choose the coal for a particular industrial use. In last class, we discussed fuels, classification of fuels, solid fuels. As a solid fuel, then we have taken coal as the example, and we discussed how the coal is producing. Whatever the coal which was produced, that should be analyzed because the composition of coal will be in different types, in different coals. It is necessary to analyze the coal sample so that type of coal can be selected for a particular industrial use. So here we are analyzing the coal. To analyze the coal, here we can take two types of analysis. One is proximate analysis, the second one is ultimate analysis. The proximate analysis, which is proximal and which can record the moisture content, volatile matter, ash content, and fixed carbon which is present in the coal. Here we can see which includes the determination of moisture, volatile matter, ash, and fixed carbon. This gives quick and valuable information regarding commercial classification and determination of suitability for a particular industrial use, which is about proximal analysis. A second type of analysis is ultimate analysis, which includes the determination of carbon, hydrogen, nitrogen, sulfur, ash, and oxygen, which is the qualitative analysis. By using of analysis, we can determine the elements, which is also called elemental analysis. This ultimate analysis is essential for calculating heat balances in any process for which coal is employed as the fuel. This is about ultimate analysis. Now we will go proximate analysis one by one. It involves the determination of moisture, as we know that it involves in the determination of moisture, volatile matter, ash content, or fixed carbon. Now we see moisture content. To determine the moisture content, first, which is experimental analysis. Here we have to take a coal sample, a minimum of 1 gram of coal. That should be hair dried coal. That should be heated about 105 to 110 degrees centigrade in a silica crucible or muffle furnace for 1 hour. Okay, here we can see moisture is generally determined by heating a known quantity of air dried coal to 105 centigrade to 110 degrees centigrade for 1 hour and calculating loss in weight as percentage. Here we need to take which is in percentage basis. Here the percentage of moisture is equal to loss in weight by weight of coal taken into 100. And next one is volatile matter. The formula for the moisture to determine the moisture is percentage of moisture which is equal to loss in weight by weight of coal sample into 100. Okay. Next one is volatile matter. Volatile matter is determined by heating 1 gram of air-dried coal exactly for 7 minutes in a transparent silica crucible of specified dimensions at a steady temperature of 925 degrees centigrade in a muffle furnace. Here is also same thing we have to do. We have to take 1 gram of sample of coal in a silica crucible that should be heated about 925 degrees centigrade in a muffle furnace. And here we can see the loss in weight calculated as percentage basis, and the percentage of moisture gives the minus the percentage of moisture gives the percentage of volatile matter. Here we can see percentage of volatile matter which is equal to loss in weight due to removal of volatile matter by weight of coal sample taken into 100. This is the process of determination of volatile matter. And next one is, here we can see here loss in weight due to removal of volatile matter is equal to weight of the coal. That means whatever the residue is remained in the crucible after the removal of volatile matter, after removal of moisture, we should be minus weight of coal or residue after removal of volatile matter. Okay, next one is determination of ash content. To determine the ash content, also we have to do is ash is determined by heating at 400 degrees centigrade a known quantity of powdered sample until most of the carbonaceous matter is burnt off, and then heated for 1 hour at 750 degrees centigrade to complete the combustion. The weight of the residue remaining in the crucible corresponds to the ash content of the coal, which is reported on the percentage basis. Okay. Same thing here also we have to take sample of coal and that should be heated about 400 degrees centigrade for 1 hour in a muffle furnace. Residual coating whatever remains it will be that we need to take. Here the formula will be percentage of ash is equal to weight of ash left by weight of coal taken into 100. Next one is fixed carbon. Fine. Next one is fixed carbon. Here we see fixed carbon, the sum of total of the percentages of volatile matter, moisture, and ash subtracted from 100 gives the percentage of fixed carbon. Percentage of fixed carbon is equal to 100 minus percentage of moisture plus volatile matter plus ash content. This is about the determination of fixed carbon. See, we have to see significance of each matter. Okay, moisture. If you take moisture, what will be going to happen if moisture is present in excess of in excess amount? See, excessive moisture content increases the cost, handling, and transportation of coal. A considerable amount of heat is wasted in evaporating the moisture during the combustion. Moisture reduces the calorific value. These are the disadvantages if the moisture is present. Next one is volatile matter. The volatile matter present in the coal may be combustible gases like hydrogen, carbon monoxide, methane, or non-combustible gases like carbon dioxide and nitrogen. The presence of non-combustible gases is always undesirable since they do not add to the heat value. When coal has high volatile matter content, then a large proportion of fuel distill over as gas or vapor. Next, significance of ash. Ash is non-combustible, useless matter which is left behind when all the combustible substances have been burnt off from coal. It reduces the calorific value of coal. It causes the hindrance to the flow of air and heat, which results in the irregular burning of coal, thereby decrease the efficiency of the coal. And next one is fixed carbon. The fixed carbon content increases from low-ranking coals such as lignite to high-ranking coals such as anthracite. The classification, we were classified the coal from lignite to anthracite on the basis of percentage of carbon only we can choose the coal. It is a fixed carbon which burns in the solid state. Information regarding the percentage of fixed carbon helps in designing of the furnace and the fireworks. This is about the proximate analysis of coal. In proximate analysis of coal, what we have discussed, this proximate analysis which determines the volatile moisture content which is present in the coal, volatile matter, ash content, and fixed carbon. All these are undesirable in coal actually. Okay, this is about proximate analysis. And the second type of analysis is ultimate analysis. This ultimate analysis is also called elemental analysis, which can help to determine the elements. This ultimate analysis is also called qualitative analysis of the coal. Here we can see how we can analyze the elements. First, we are going to see about elements of carbon and hydrogen. See here, we have to take 1 or 2 grams of accurately weighed coal sample is burned in a current of oxygen in a combustion apparatus. To analyze this coal, we can choose combustion apparatus. Here we have to take 1 or 2 grams of accurately weighed coal sample, which should be burned in a current of oxygen in a combustion apparatus. Here we can see carbon and hydrogen of the coal are converted into carbon dioxide and water respectively. Here we can see this, if you observe this combustion apparatus, this is the combustion chamber, combustion operator. When we pass this coal sample through this combustion operator, first we have to send the coal, it's passed through the 2 bulbs here. Here 2 bulbs we are observing. We have to send the sample of coal through these bulbs. Here 1 bulb containing a wide amount of anhydrous calcium chloride. 1 bulb which containing anhydrous calcium chloride, which absorbs water which is present in the coal sample. In this calcium chloride bulb, which will absorb the water, and another bulb which containing potassium hydroxide, KOH. This potassium hydroxide bulb, here we can see potash bulbs which can absorb, which absorbs carbon dioxide which is present in the coal sample. Here we can see, here we can see the reactions. What will be going to happen? First, what we are doing is, we are determining the carbon and hydrogen elements by using of combustion chamber. For this purpose, we are taking a wide amount of coal sample that should be sent to the combustion chamber. The carbon and hydrogen present in the coal sample, these two are converted into carbon dioxide and water. Then which are passed through two bulbs. Here one bulb is containing anhydrous calcium chloride. Second bulb is containing potassium hydroxide bulb. This anhydrous calcium chloride bulb which absorbs the water and potassium hydroxide bulb which absorbs the carbon dioxide. How now we can see the reactions what will be going to happen here. See, carbon which is reacting with oxygen. We know that this combustion chamber already oxygen will be there. So that when the carbon is reacting with the oxygen, which is converting to carbon dioxide. And then here hydrogen is also present in water, coal sample, sorry. This hydrogen, when it is reacting with the oxygen, which is getting converted to water sample. Here we can see the molecular weight of carbon is 12, oxygen will be 32, carbon dioxide will be 44, and then hydrogen atomic weight is 2. Here we are taking off of the oxygen. Here this one is 16. Totally the amount which is generating the weight is 18. See, if you take this, 12 grams of carbon produces 44 grams of carbon dioxide. Then how much of carbon produces the number of suppose X amount of carbon dioxide? That can be calculated on this basis of this formula. See here, therefore percentage of carbon is equal to increase in weight of potassium hydroxide bulb by weight of coal sample taken into 12 by 44 into 100. This is the formula to determine the percentage of carbon. And the second one is percentage of hydrogen. To determine this, we have the formula again. Here I have explained here, see, weight of hydrogen 2 and which is generating 18 moles of water. See, increase in weight of calcium chloride bulb by weight of coal sample taken into 2 by 18 into 100. This is the formula to determine the carbon and hydrogen. Okay. And see here, and next one is determination of nitrogen. We discussed now determination of carbon and hydrogen. To determine this carbon and hydrogen, we will use combustion operators. And second one is determination of nitrogen. To determine this nitrogen, we are using the Kjeldahl's method. Okay, here we are taking Kjeldahl's operator. See, this is the diagram for this experimental process. See what will be going to happen. Here we have to take 1 gram of powdered coal in a preheated concentrated sulfuric acid along with the potassium sulfate which is acting as a catalyst in a long necked Kjeldahl's flask. This is the Kjeldahl's flask. In this we are taking what we are taking? Wide amount of powdered coal along with the sulfuric acid followed by potassium sulfate. Okay, and next one, see here, when the solution becomes clear, it is treated with the excess of potassium hydroxide. After treating of this solution, this should be treated with, we need to add potassium hydroxide to particular solution. Here, whenever this potassium hydroxide is added to this here, it will be liberating ammonia. Ammonia will be liberated. And next one is, whatever the liberated ammonia is distilled over and absorbed in a known volume of standard acid. Okay, here whatever the unused acid is there, then it should be determined by the back titration with standard sodium hydroxide solution. This is the operators, called as operator. See, if you see this, what are the reactions are going on here? See, nitrogen, which is present in already present in coal, which is to this nitrogen we are adding sulfuric acid. So here it is producing ammonium sulfate. This ammonium sulfate treated with the sodium hydroxide, which is liberating sodium sulfate and ammonia and water. Okay, finally the ammonia, whatever the ammonia is there, that is treating with the hydrogen sulfate again, sulfuric acid, sorry, and it is generating ammonium sulfate. See, to determine this ammonia from the volume of acid used by liberated ammonia, the percentage of nitrogen in coal is calculated. How we can calculate? The percentage of nitrogen is equal to volume of acid used into normality by weight of the coal taken into 1.4. How we can get it is, so here we have to take percentage of nitrogen is equal to volume of acid used into normality of acid by the weight of coal sample taken into 14 by the 1000 into 100. Then we will get the 1.4 value here. Okay, this is about the determination of nitrogen. Now we have completed carbon, hydrogen, nitrogen, and next one is sulfur. If you see the determination of sulfur, sulfur is determined from the washings obtained from the known mass of coal used in bomb calorimeter for the determination of calorific value. To determine this sulfur, we have to take bomb calorimeter. You can determine in the bomb calorimeter. Ash from the bomb calorimeter is extracted with acid. The acid extract is then treated with barium chloride solution to precipitate sulfate as barium sulfate. The precipitate of barium sulfate is filtered, washed, dried and heated to constant weight. See, here we can see sulfur, which is treating with the oxygen. In bomb calorimeter, oxygen will be there, which is producing sulfur oxide, which is treating with the barium chloride, then which is producing barium sulfate. The molecular weight of sulfur is here 32, which is converting to barium sulfate. The molecular weight of barium sulfate is 233. Now, if you see here, 32 grams of sulfur produces 230 grams of barium sulfate. How much of sulfur produces suppose x grams of barium sulfate? If you see that, the percentage of sulfur is equal to weight of barium sulfate by weight of whole sample taken into 32 by 233 into 100. This is about the determination of sulfur. Next one is determination of ash. Already we discussed determination of ash in proximate analysis, which is as determination is carried out as in proximate analysis. Next one is determination of oxygen. It is determined directly by deducting the combined percentage of carbon, hydrogen, nitrogen, sulfur and ash from 100. Here we see that percentage of oxygen is equal to 100 minus percentage of carbon plus hydrogen plus sulfur plus nitrogen plus ash. All the percentages we should take here. This is about the determination of oxygen. Here also we have to look into observed significance of ultimate analysis. If you see, the most desirable element of coal is carbon, because the calorific value of any fuel depends upon the percentage of carbon. Higher the percentage of carbon, higher the calorific value. The percentage of carbon varies in different sample of coal. Here we can see that carbon and hydrogen in coal directly contribute towards the calorific value of the coal. Higher the percentage of carbon and hydrogen, better is the quality of coal and higher is its calorific value. Okay, next step. Nitrogen, the least desirable element. Nitrogen is least desired element of coal. The presence of nitrogen does not affect to a great extent in utility of coal, since it is present to a little extent and it is an inert gas. Okay, origin of nitrogen in coal is proteins, chlorophyll, and alkaloids. Nitrogen in coal does not contribute any useful value to the coal, and it is generally present in very small quantity, that is up to only 1%. Next, since the nitrogen is an incombustible gas, hence its presence in coal is undesirable. Okay, and next one is sulfur. Sulfur is usually present in amount of 0.5 to 3% and is derived from ores like iron pyrite, gypsum, and etc. In the sulfur, sulfur when present in coal adds to its calorific value, as the oxidation of sulfur is an exothermic process to a little extent, which is the exothermic process, but sulfur dioxide produced a harmful one. But when the sulfur is reacting with oxygen, which is producing sulfur dioxide, which is very harmful because it gets oxidized to sulfur dioxide, which forms sulfuric acid. The formation of this sulfuric acid, which leads to the corrosion. Okay, corrosion is nothing but rusting of materials. During these metallurgical operations, sulfur is introduced into the molten metal, causing disadvantages to the metal. For example, sulfur content in cast iron causes brittleness and red short conditions. Hence, sulfur content in coal is least desirable one. Sulfur present in coal contributes towards the heating value of the coal. See, here we can see its combustion products, sulfur dioxide and sulfur trioxide, have corrosive effect on the equipment, especially in the presence of moisture. The oxides of sulfur are undesirable from the atmospheric pollution point of view. Sulfur containing coal is not suitable for metallurgical use, as is adversely affect the properties of the metal. And next, oxygen. See, oxygen content of coal is generally associated with moisture. Thus, hydrogen available for combustion is less than the actual one. See here, this oxygen which is present in coal sample in the combined form as inherent moisture, which causes low calorific value. That means which is having low cooking power. An increase in 1% of oxygen decreases calorific value by 1.7%. Hence, a good quality of coal should contain low percentage of oxygen. Here we can see oxygen content of coal is generally associated with moisture, thus hydrogen available combustion is less than the actual one. See, as the oxygen content increases, the capacity of coal to hold moisture increases, its calorific value decreases. An increase in 1% of oxygen content decreases the calorific value by about 1.7%. Thus, a good quality coal should have low percentage of coal. This is about the analysis of coal. What we discussed, proximate analysis. In proximate analysis, we were discussed the moisture content, volatile matter, ash content, and fixed carbon. This is this proximate analysis, which is proximal. Okay, hence it is called proximate analysis. And second one is the ultimate analysis. In proximate, what we discussed, moisture content, volatile matter, ash content, fixed carbon. All these are undesired to the coal sample. Due to the presence of all these matter, coal will not give the high calorific value. So we need to remove all these matters from coal sample. Now, second one is the ultimate analysis. This ultimate analysis, elemental analysis. In this ultimate analysis, we also call as a qualitative analysis of coal, because this analysis involves in the determination of carbon, hydrogen, oxygen, nitrogen, sulfur, which is also called elemental analysis. This ultimate analysis is essential for calculating heat balances in any process for which coal is employed as a fuel. By using of this, we have determined carbon and hydrogen. How we can determine the carbon and hydrogen? By using of combustion chamber. Second one is determination of nitrogen. By using of Keldar's operators, we can determine the percentage of nitrogen. The second one is the determination of sulfur. By using of bomb calorimeter, we can determine the sulfur content which is present in the coal. Next, also we can determine the ash content, which is already which is carried out in proximate analysis. And next one is the oxygen, determination of oxygen. By taking off all the percentages of, it should be minus from 100 total amount. This is about the analysis of coal sample. This is our today's topic. Thank you.